Hello, in this video we will look at one way in which some of the equations for simple harmonic motion are constructed. What we're going to do, we're going to model the motion of a point P, which is going around a circle with an angular velocity omega and an angle theta. We can start with point P here, and the P is going to go rotate in that direction. We're going to start with a variable time equals 0 when displacement x equals 0. What I mean by that is we are only looking at the at whereby the point is on the x-axis. So we're converting two dimensions, which is y and x, just to one dimension. So therefore, effectively, the point will oscillate from there back to there, through there, and back to there again, in one dimension. So if we look at the trigonometry of the situation, if we've got theta increasing in that direction, we'll find that A, which is the amplitude, the maximum maximum displacement, multiplied, which is like the hypotenuse, multiplied by the sine of theta, will give us this dimension here, forming a right angle triangle, and then that would also give us this dimension here, which will give us the point of P transposed onto the x-axis only. So we can then start the mathematics with saying that the displacement on x is equal to the amplitude times the sine of this angle theta. Now, the angular velocity omega is equal to the change in theta over time. So therefore, the angle theta can be written as omega t. So we're going to rewrite this equation. A equals A sine omega t. We're then going to differentiate it to find the velocity. So dx, we'll differentiate with respect to time, omega being constant. So dx dt, which equals the velocity, is equal to a omega cos omega t. We're now going to differentiate it again with respect to time to give us the acceleration is equal to the acceleration, which is equal to minus a omega squared sine omega t. Now, we see up here that x equals a sine omega t. So we could write the acceleration as minus is equal to, rather, minus a, minus omega squared x. So acceleration is equal to this thing known as now it's called the angular frequency, because it's angular velocity before, but now it's known as the angular frequency. So omega now, so this is for circular motion, and it's transformed itself into something known as angular frequency, which we defined in the earlier lesson. Now, at the maximum acceleration is at the far point when we have x equals a. So the maximum acceleration is equal to minus omega squared a. Another equation that I won't derive, but can be calculated using trigonomic identities, is that the velocity, as well as equal to a omega cos omega t, the velocity is also equal to angular frequency omega multiplied the square root of the amplitude squared minus the displacement squared. Now, I'll just rub a bit of space. That equation there, okay, will maximise, so I'll rub a bit of space here. That equation there will maximise in the middle when x is 0. So, if you like, if that's max acceleration, the maximum velocity will be equal to, so when x is 0, that's square root of a squared is equal to omega a. So, these are two very useful equations to use. Okay, now we'll go a little bit further. I'll find another, we'll derive another equation using the fact that acceleration is equal to omega squared x. So, from this little bit of derivation, we found that the acceleration is equal to minus omega squared times x. Now, from earlier, from the first video on simple harmonic motion, we said that the force is equal to minus kx. This is what is required for simple harmonic motion. So we can write that as ma is equal to minus kx. Now, of course, the acceleration equals omega squared x, so we can write that as m omega squared x minus equals minus kx, and we find that x will cancel. In fact, the minuses cancel as well, to give us the very useful relationship that omega squared is equal to k over m, or omega is equal to the square root of k over m. This being the angular frequency. Now, in all the previous equations, such as x equals a sine omega t, that can be also written as x equals a sine 2 pi ft, because omega is equal to 2 pi f.